Okay, good afternoon. So, shall we start? So, we are discussing regarding to we have completed biofuels, biogas, and biomass. Okay, no? Next one is oceanic energy resources. So, what are the different oceanic energy resources that we are extracting? That is wave energy, tidal energy, ocean, thermal energy conversion. So, this is what regarding this. Then wave energy, tidal energy, ocean thermal energy conversion. How these waves in the ocean are produced? How these tides in the ocean are produced? How tides are and oceans are waves are produced? Just simple basic. First, we need to know about these basics. First, what is that wave and tide? Anything? You think you have some knowledge, but you are unable to express? Huh? Yeah? Okay. No. No. What is the driving force for formation of waves and tides? There should be some driving force. Huh? Yes, yes, that's what I'm expecting. Tides are produced due to the gravitational pull of moon, only moon, so only sun, both, only both. Okay, and not the earth. Okay, there is no role of earth. There is. Okay, along with moon and sun. Okay, earth also has its own role in this tidal formations. Okay, and next one is so only sister for sun and moon is earth. Okay, so that is gravitational pull of earth, moon, and sun results in formation of tides. And what about waves? When winds are moving from one place to the other place, when winds comes into contact with water, and this whatever the energy that is present in the wind will be transferred in the form of waves. That is how waves will be generated in the oceans. India has longest coastline. What is the coastline of India? Total coastline of India? Approximately. I'm able to hear 7,000. After that, I want 7,516 kilometers. This is what the coastline. Because of its huge coastline, estimated potentiality of wave and tidal energy is also very high. We have not yet established wave energy plant. Only experimental wave energy plants is there in Kerala. But commercial production of tidal energy is there in West Bengal, Gujarat, and Tamil Nadu. They started extracting this tidal energy. Okay, so these are the two things regarding to this. And when it comes to the ocean thermal energy conversion, so what is this ocean thermal energy conversion means? Regarding to this ocean thermal energy conversion, so it is one of the indirect form of solar energy students. Listen carefully. It is one of the indirect form of solar energy. What is this indirect form of solar energy means? So sun, what sun will do is sun will heat the sun rays, will heat the water in oceans. This is the ocean. Okay, this is an ocean. Think like that. Okay, this solar energy will heat the water. You know that from sun we get two types of energy. One is what is that? Light energy as well as heat energy. Okay, and this heat energy, what this heat energy will do? It will heat the water in the surface. Okay, and next one is as we go deep into the oceans, what happens means temperature decreases. At certain point, what will be there means thermal gradient will be established. Thermal gradient of 30 degrees to 10 degrees. Thermal gradient will be established that we call it as a thermocline. That we call it as a thermocline region. And see, from here we will extract hot water. From here we will extract cold. This is a cold phase, and this is an hot phase. Okay, from the bottom we will extract cold water. From the top we will extract hot water. Okay, and we use it for different purposes. And whatever the hot water and cold water we are extracting, we use it for what purpose means? This hot water, with the help of hot water, we will convert ammonia into steam. And steam is further used for rotation of turbines. Rotation of turbines, and turbines results in production of electricity. And what is the use of cold water means? With the help of this cold water, whatever the steam is there, again it is converted into ammonia. With the help of what means? Cold water. That is how electricity is produced in case of ocean thermal energy. So we will use sunlight and we will produce electricity. Ocean thermal energy conversion in India, we are going to establish India's first indigenously developed ocean thermal energy conversion in Lakshadweep Islands. Okay, and it is used for desalination purpose. Desalination means conversion of salt water into the fresh waters. For that purpose, we are using this. Got the point, students? Is it clear? And due to the longest coastline of India, ocean thermal energy availability is also very high. After solar and wind, it is the third renewable energy which is having highest estimated potentiality. Okay, that is what ocean thermal energy conversion means. Oceanic resources means. Okay, copy that flowchart. Copy that flowchart. No? Copy that flowchart first. Yes. Once again I will explain. Okay, listen carefully. Not only ammonia part, I will explain everything. So from sun, we get heat energy. That heat energy will heat the surface water. Up to some extent, these temperatures will enter into the water now through conduction and convection mechanism. Okay, now. So it will reach, say for example, up to certain depth it will reach. It will reach up to certain depth zones. So this thermal gradient will be formed at 100 to 1000 meters of depth. At any of this depth, this thermal gradient might be formed. Why? Because the heat energy on the surface of water will reach the greater depths. Okay, now, through conduction or convection. At a certain point, this thermal gradient will be formed. That point may be between 100 meters to 1000 meters. Okay, now, at this point, the temperature difference is how much? 20 degrees. Okay, now, so at 20 degrees, we can't produce steam. Rather than using a steam, I will say it as a vapor. Okay, now, you can write vapor and steam both here. Why? Because why I am using this vapor and steam both the technologies. If it is a water, at 20 degrees centigrade, we cannot convert water into steam. At 100 degrees only, we can convert water into steam. Because the boiling point of water is 100 degrees. But when it comes to ammonia, ammonia has less boiling point. When it is a less boiling point, we can convert at less temperature, 20 degrees centigrade, into steam. Because ammonia is highly volatile liquid. Okay, now, at normal temperatures, it will be converted into vapors. Okay, now, at 20 degrees centigrade, we can produce steam from ammonia. Okay, now, hence, we will take the hot water and we will heat the ammonia. Ammonia will be converted into steam. Okay, now, that steam we use it for rotation of turbines and it results in production of electricity. And with cold water, what we will do is, again, we will condense the steam or vapor and we will convert it into ammonia. This cycle happens frequently like this. On one side, electricity will be generated and we will use hot and cold water like this for the production of electricity. In both the ways, it is useful or not. Okay, like this. So here, this kind of energy production we are focusing in where means islands of India, where electricity generation is not possible through other sources. This is what we are using in islands. India's first indigenously developed ocean thermal energy conversion plant is going to be established at Lakshadweep Islands. For what purpose we are using it means desalination purpose. So where do we get ammonia? We won't get ammonia from oceans. We will produce it in the chemical plants and we will take the ammonia to the particular areas. We will use ammonia as a intermediate product. Got it? That is what the thing is. Is it clear now? Shall I dictate it? Okay, make a note like this: ocean thermal energy conversion. It is an indirect form of solar energy. It is an indirect form of solar energy. In this energy resource, sunlight will heat the surface waters. And heat energy from the surface water will reach the greater depths through convection and conduction. At a depth of 100 to 1000 meters, thermal gradient will be established. With a temperature difference of 20 degrees. At these temperatures, cold and hot water exist on both sides of thermocline region. Cold and hot water exist at both sides of thermocline region. Hot water is used for converting ammonia into steam, which is further utilized for production of electricity. Okay, next one is cold water is used for condensation of ammonia. From steam into liquid. From steam to liquid. Okay, next one is India's first indigenously developed ocean thermal energy conversion plant. Will be established at Lakshadweep Islands. And it is used for desalination purpose. Desalination means, right in the bracket, conversion of salt water into fresh water. Conversion of salt water to the fresh water. Next one is. So take a note and write like this. Note as a side heading or point to be remembered. Take heading point to be remembered. Ocean thermal energy conversion. Ocean thermal energy conversion is possible only in tropical and subtropical regions of the world. Is possible only in the tropical and subtropical regions of the world. Tropical and subtropical regions of the world. Because of plenty of sunlight availability. Because of plenty of sunlight availability. Because of plenty of sunlight availability. Got clarity? Next one is ocean thermal energy. Ocean thermal energy. After solar and wind. After solar and wind has huge estimated potentiality. After solar and wind has huge estimated potentiality. That is, right in the bracket, that is 1,80,000 megawatts. That is 1,80,000 megawatts. 80,000 megawatts. It is due to the longest coastline of India. It is due to the longest coastline of India. Right in the bracket, 7,516 kilometers. Is it clear now? Everything clear? Any doubt? Shall I proceed to the other one? Okay, na? Is it okay or not? Okay, Sunday also you can talk. Okay, na? Weekend you have to talk more. Okay, na? Next one is tidal energy. Tidal energy. Tidal energy. Tides in the ocean are produced. Tides in the ocean are produced. Tides in the ocean are produced due to the moments of gravitational pull. Due to the gravitational pull of sun, moon, and earth. Sun, moon, and earth. The next one is in India. The total estimated potentiality of tidal energy is 12,455 megawatts. 12,455 megawatts. And it is concentrated in the following three states. First one is Gujarat. If it is Gujarat, where it is? In Gujarat, it is concentrated in Gulf of Cambay and Gulf of Kutch. Okay, now next one is, first write that, Gulf of Cambay, Gulf of Kutch. Next one is another one after this. Tamil Nadu. If it is in Tamil Nadu, where it is? Palk Bay, Mannar Channel. Palk Bay and Mannar Channel. Palk Bay and Mannar Channel, Tamil Nadu. In West Bengal, where it is? Hooghly River, South Haldia, and Sundarbans. In Sundarbans, South Haldia region, Hooghly River. So these are the three areas where tidal energy is concentrated. Okay, now ocean thermal energy is possible only coastal regions. Is possible only in the coastal region. That too, where thermal gradient will be there. That's all. Okay, now, and this is what about tidal energy. Got clarity? Next one. Shall we go for another one? Next one is wave energy. What about this wave energy? So on where it meets the ocean like that. Okay, now. So that is next one is wave energy. It is an indirect form of solar energy. It is an indirect form of solar energy. It is an indirect form of solar energy. Because wind's movements are always determined by the pressure belts. Wind movements are always determined by the pressure belts. Is it okay or not? Okay, no? That is. When winds are moving from one place to the other place, when winds are moving from one place to the other place, when winds are moving from one place to the other place, when it comes into the contact with water, when it comes into the contact with water, when it comes into the contact with water, comes into contact with water, it moves the water in the form of waves. It moves the water in the form of waves. Okay, no? Water in the form of waves. That is known as wave energy. That is known as wave energy. Okay, no? Which one is that is what regarding to this wave energy, students. Estimated potentiality of wave energy in India is estimated potentiality of wave energy in India is 40,000. Estimated potentiality of wave energy in India is 40,000 megawatts. 40,000 megawatts. 40,000. Okay, no? 40,000 megawatts. But experimental plant is there, but commercial production was not yet started in India regarding to this wave energy. So waves are produced due to the moments of winds. Tides are produced due to the gravitational pull of moon, earth, and sun. So height of the tides is very high compared to the waves. Okay, now, hence it is easy to produce tidal energy than wave energy. Is it okay, students? And what is there is a doubt from online. What is the role of thermocline region? Thermocline means nothing but temperature gradient. Temperature gradient means nothing but hot and cold phase. Hot water we are using it for what purpose? You know that now? Okay, now, and cold water for what purpose we are using it? Okay, now, that difference wherever it is there, we call it as a thermocline. Thermocline may establish at 100 meter depth. It may establish at 1000 meter depth. It depends upon the penetration of sunlight into the water bodies. Am I right or not? Okay, now, that is what ocean energy. Oceanic energy. See this previous question. Tides occurs in the ocean and seas due to which of the following? Gravitational force of sun, gravitational force of moon, centrifugal force of earth. What is that? one end, one to end, 3. Okay, now centrifugal force of Earth. Okay, now understood or not? Okay, now so that is on one side it is a gravitational pull, on the other side it is an centrifugal. Why? Because wait, I will explain. Waves means tides. It seems to be traveling in the form of crust and trough. Okay, now so you know that it is like this. It seems to be. It is moving like this only now. We see in the form of crust and trough. But inside what happens? It moves in a circular form like this. Water will be moved in a circular form like this. Then centripetal and centrifugal force comes into the actions. Are getting my points, friends? So that is how the answer is all the three. Got the clarity, friends? Tidal. In geography, they will explain you in a better manner. Okay, that is what regarding to this question is, and that is what oceanic energy resources. If you are unable to understand, come after the class. I will explain you with picture, drawing picture. Okay, okay. Next one is yes. See, for all the renewable energy resources, when you are writing the question related to renewable energy resources, except wind and a few biomass like that, remaining all other renewable energy resources, first point in challenges you can write lack of technology in India. You can use this point for any other renewable resources. Tidal also we are importing it from other countries only. When we are importing it from other countries, technological cost will be very high. Got it, friends? Okay, so that is what wave and tidal energy. Next one is we will go for another one is wind energy. What is this wind energy? So how we will extract this wind energy? In what way we are extracting this wind energy, friends? So you know that how this winds moves from winds always moves from high concentration to the low concentration. Okay, now when winds are moving from high concentration to the low concentration, so what we will do? That means not high concentration to low concentration, high pressure to low pressure. That is exact thing is high pressure areas to the low pressure areas like this. So when winds are moving from high pressure areas to the low pressure areas, what we will do is we will establish wind turbines. Think it as wind turbine. Okay, now we will establish wind turbines like this. And by establishing wind turbines, what we will do? We will convert kinetic energy in wind into the not potential energy, electrical energy. Okay, now. Okay, now. And next one is mechanical energy is converted to electrical energy. Okay, now. So wherever this tidal farms, all this group of tidal farms means tidal, what we call it as a tide, not tidal, this wind farms. All these wind turbines we call it as a group of wind turbines together. We call it as what means wind farm. We call it as a wind farm. Okay, now. And these are what we call it as wind turbines. And all this wind turbine together we call it as wind farms. Does this wind farms can be established in any area? Is it possible to establish in any area, students? No. Where we can establish this? You said no very strongly. Okay, then what? Then where we can establish it? Only in coastal areas, desert areas. So can I write like this? Like in open plains. In open plains. Okay, now we can establish. And next one is top of mountains, hills, and buildings. Okay, next one is between the mountains. Next one is in coastal areas as well as in mid oceans. Coastal areas as well as in mid oceans. So these are the areas where wind farms can be established. Okay, who is that? Sometimes he will wake up suddenly. Okay, now. Mechanical energy is converted to electrical energy like this. So this is what regarding to this wind farms, where the wind farms can be established. So they may ask the question that open plains in urban areas. Is that correct? In question, if they give open plains in urban areas, no, we can't establish there. Okay, now. So that is one of the exception limitation there. So hence we can't establish wind farms as if we want. And that too, wind energy is confined to only few states. And wind energy is seasonal in nature. Seasonal impacts are there. But in India we have well developed wind technology. Hence more power production is possible from this wind energy source. Okay, now. Done with this? Are you able to see this? Okay. Okay, is it okay now? Make it fast. Okay, now in which states? In only 7 states that wind energy production is possible, friends. Yes, I will list it out. I will list it out. Yes, no doubt. Gujarat is there. Rajasthan is there. Okay, now Tamil Nadu is there. I will remaining I will tell. Okay, now how this wind energy potentiality will be estimated? So on basis of what this wind energy potentiality will be estimated, friends? It will be estimated based on the altitude. Okay, now so from the mean sea level, so they will take the what we call it as a base. From the mean sea level, they will estimate the potentiality of wind energy to the particular height. So what height it will take? This is a mean sea level. From the mean sea level to the height of, first they will take the 50 meters of height, and later they will take the 100 meters of height, and they will go for later 120 meters of height, 120 meters of height. Like this, from the mean sea level to the certain altitudes they will take, and they will measure the wind energy. How much of wind energy is there? At 50 meters of height, so what is the estimated potentiality of wind energy in India is, here it is 60 gigawatts. At 100 meters of height, wind energy potentiality is 302 gigawatts. At 120 meters of height, wind energy potentiality is 695.5 gigawatts. So like this, they will measure the wind energy potentiality. What is the technology they use? what is the technology they use in measuring of wind energy potentiality means they use lidar technology. They use lidar technology in estimating the wind energy potentiality storms. So from the mean sea level to altitude of 50 meters, 100 meters, and 120 meters they will take. They may go for 150 meters also. So that is how estimated potentiality means wind potentiality of India will be measured. Which organization is involved in measuring of wind energy potentiality means what is the organization that is involved in measuring of this wind energy potentiality means National Institute of Wind Energy. National Institute of Wind Energy. National Institute of Wind Energy, which was established in Chennai, is involved in estimation of wind energy potentiality, as well as it also gives permission for establishing of wind power plants. National Institute of Wind Energy, which was established in Chennai, will estimate the wind energy potentiality in India. Will estimate the wind energy potentiality in India, as well as will give permission for, as well as it gives permission for establishing of wind power plants. As well as it gives permission for establishing of wind power plants. Okay, now you can copy this. If anybody need to be copied, please make a note of it. Understood this? Understood how the estimated potentiality will be calculated? So what is the technology they use? Lidar. Lidar is one of the remote sensing technology or not? Yes. Sonar is one of the remote sensing technology. Lidar is one of the remote sensing technology. Radar is one of the remote sensing technology. Along with this, hyperspectral is one of the remote sensing technology. All these things I have mentioned in the remote sensing. Okay, now. So that is we use in lidar white light to measure this wind energy potentiality of India. Lidar means, make a note of that, light detection ranging technology. What is this lidar means? Light detection ranging technology. Light detection ranging technology. Light detection ranging technology. Okay, next one is after this. Okay, so wind, make a note like this. In India, wind energy is confined to the following states. That is Gujarat, Rajasthan, Maharashtra, Tamil Nadu, Madhya Pradesh, Karnataka, and Andhra Pradesh. Got it? So these are the, how many states total? 7 states. 7 windy states. Okay, friends. Got clarity? So these are the 7 windy states where wind power production is possible. Next, after this. So I told you that India has well-developed technology of wind energy. But the problems regarding to this wind energy is what means. So wherever wind plants are there large number of birds are dying. Birds plays a key role in ecosystems now. Okay, they are the keystone species. They control the other species populations. Got it, friends? Birds helps in pollination. Birds helps in transfer of seeds. Okay, birds will control the insect population. If birds are not eating insects, what we have to do? We have to eat. Already we are eating everything except virus. We are eating everything now. We see everything in positive in non-vegetarian food. Okay, now. So, but even though we are eating, insect population cannot be controlled. Okay, now, like that. So if birds are not there, food chain of the ecosystem will be disturbed. So hence that we are going to face a severe problem with wind turbines. When wind blades are rotating, they are unable to detect. Hence, accidental hits are leading to the death of the birds. Noise pollution from these plants. And next one is they are not established in normal areas where they doesn't have access. Okay, now. Hence, because of these remote locations, maintenance and operation cost is also very high. And we need to acquire large area of land for this. These are the practical problems. And to overcome these practical problems, now government of India started focusing on establishing of wind power plants in coastal areas and mid oceans. If it is in coastal areas, no bird movement will be there. Wind velocity will be very high. No need of acquisition of land. Okay, now all the problems can be overcome except the installation cost. Okay, now hence we are focusing in coastal areas. We have a lot of coastal area now. Okay, now, and whereas when it comes to the land acquisition, as I told you that on one side we are going for development, on the other side we are establishing the solar and wind power plants. In between, this Indian population is growing at a faster rate. Everything requires land. Land scarcity levels are increasing, and it becoming too costly commodity. Okay, now hence we are unable to acquire the land. In such cases, coastal areas is one of the best alternative to it. No doubt that positives and benefits will be there, but when we weigh the positives and benefits, so benefits are more. Hence, we started focusing on coastal areas as well as in mid oceans. Got clarity, students? Make a note like this. Even though India is having well-developed wind energy technology, there are certain limitations. What are those certain limitations means? First one is installation cost is very high because of its remote locations. Installation costs are very high because of its remote locations. Okay, no? That is one thing. Next one is, other than this, large number of birds are dying. And it's showing impact on food chain of ecosystems. Large number of birds are dying, hence it is showing impact on food chains of ecosystem. Done? Next one is, acquisition of land is major task. It's a difficulty task. Acquisition of land is a difficulty task. Next one is, other than this, noise pollution. Noise pollution is dangerous pollution or not? Yes, it have a permanent addiction on humans, and it shows severe impact on human health. This is one of the major problem what many people are facing in India now currently. Okay, a person who is working in railways, after retirement also he will prepare the bed like a railway breath, and he will have a ringtone of a railway horn, because if he didn't experience these two things in daily basis means he will become mad. Is it right or not? Yes, he has to continuously listen to the particular sounds because he have listened it for past 40 years like that. Suddenly if you stop these sounds, they can't work. They can't behave normally. Okay, that is what the impact of noise pollution on humans. Got it? That is what. And to overcome all these problems, now we are focusing on what means offshore wind farms. Okay, now make a note of this. To overcome the above limitations, to overcome the above limitations, to overcome the above limitations, government of India is focusing on. Government of India is focusing on. Government of India is focusing on offshore wind farms. Offshore. OFF. Off. SHORE. Shore. Offshore wind farms. Okay, now. So that is what is the except one limitation we can overcome all. What is the limitation that we can't overcome? Installation costs. Except installation cost. Okay, now write in the bracket except installation cost. Write in the bracket except installation cost. Except installation cost. Done? Clear? Okay, friends. That is what regarding the wind energy. Okay, now next one is other energy resources. What means geothermal energy. We'll go through the geothermal energy. What is this geothermal energy means? So the name itself is saying what? Geothermal energy. Is it right? What is this? Geo means earth. Thermal means heat. Okay, now heat energy that is extracted from the interior layers of the earth crust. We are extracting this heat energy from the interior layers of the earth crust. We call it as a geothermal energy. So generally in some areas you might have heard about this. This heat energy will reach the surface of the earth in two ways. Okay, now one is through borewell, digging of borewells. By digging borewell, we will extract the heat energy. In some areas, naturally it comes to the surface of the earth through cracks. Is it right or not? Okay, now, and this forms a pool-like structure, and we call it as a geysers. Okay, now this is what happens naturally, but this is commercial purpose. So this activity is for commercial purpose, and this is naturally. Naturally, in some areas, the hot water from the interior layers of earth crust will reach the earth's surface, and it is stored in the form of pools. That hot pools we call it as geysers. Okay, now hot springs are geysers we call it. Generally that is. But here, commercially we will dig the borewells. We won't extract hot water. Hot water is not needed for us. What is needed? Steam is needed. We will extract steam, and steam is used for production of electricity. Same story. Steam is used for rotation of turbines. Turbines in turn results in rotation of generators. Generators produce electricity. Okay, now so this is what generally happens regarding this geothermal in case of geothermal energy. Okay, now but when we are digging the borewells, when we are extracting the borewell should have a temperature of above 100. If it is below 100, it is not viable for production of electricity. If it is above 100, then only it is viable for production of electricity. Okay, now why? Because at 100 degrees only water will be converted into steam. At any temperature, water will be converted into vapor. Got clarity, students? So that is what geothermal energy. That depends upon area to area. If it is, say for example, very good question. Listen carefully. So say for example, okay, I will write first flowchart, then I will make you aware of these things. Seismic activity. Have you heard about this seismic activity? What is this seismic activity means? Plate tectonics now? Is it regarding to plate tectonics or not? Okay, now plate tectonics. So next one is seismic activity is always followed by volcanic activity. Volcanic activity is always followed by geothermal energy availability. That means wherever volcanic activity is very high, there the geothermal energy availability is very high. Okay, friends. Next one is in India, based on this seismic activity, Indian mainland is categorized into 5 zones. Zone 5 is the region where earthquake activity is very high, volcanic activity will be very high. In these areas, this geothermal availability will be confined to the top layers of the earth. In zone 4 regions, what happens means we have to go for a greater depths. That depends, depth of the borewell depends upon area to area. If it is a high seismic active zone, if it is a volcanically active zone, so hot water, that is steam, is available in the surface layers of the earth. If it is not a volcanic activity area, and we have to go for the greater depths of the earth. That is how the depth of this borewell activity depends upon. Are you getting it? So next one is where this geothermal energy will be located. So if you are unable to get the steam also, what we'll do is through one pipeline we will send the water, to other pipeline we will extract steam. So like that also we can generate this geothermal energy, students. So geothermal energy is mostly confined to the means wherever high seismic activity and volcanic activity is, means volcanic active high. Okay, now means wherever this volcanic activity is very high, there the geothermal potentiality is high. Okay, now that is what we're going to this. In India, in which areas this geothermal energy, according to the Geological Survey of India, students, it is mostly confined to these areas. One is Sahara Valley, Cambay region, next one is Himalayan region, Son, Narmada, Tapti region, West Coast, that is Mahanadi basins and Godavari basin. These are the areas where this geothermal energy production is there, and mostly it is confined to the Jammu and Kashmir, Himachal Pradesh, Maharashtra and Uttarakhand regions. These are the states where highest geothermal availability is there, because they are in the zone 5 region of earthquake regions, where volcanic activity is also very high, students. Okay, now, so make a note of this geothermal energy. Copy that flowchart. Okay, now I will add few more points here. The total estimated potentiality of geothermal energy, according to the Geological Survey of India is, according to the Geological Survey of India, is 10 gigawatts. According to the Geological Survey of India, is 10 gigawatts. Nation is Jammu and Kashmir, Himachal Pradesh, and Maharashtra, Maharashtra, Jammu and Kashmir, Himachal Pradesh, Maharashtra, and Uttarakhand are the states where geothermal availability is very high. Are the states where geothermal availability is very high. Okay, no? That is. Next one is the borewell temperature should be more than 100 degrees. The borewell temperature should be more than 100 degrees. Then only it is viable for production of electricity. Viable for production of electricity. Okay, now take it in. Do you know? Right, like this. Do you know? What does that mean? Water is converted into vapor. What? At any temperature. Water is converted into vapor at any temperature. But water will be converted into steam. At 100 degrees and above. Why we use steam? Why not hot water? Okay, now, why we are using only steam? Why not hot water? We can use hot water also for generation of electricity. Write that statement. Steam has more energy than hot water. Hence, only steam can rotate turbines. Done? Got the clarity on this? Now come out of do you know and write like this. The major limitation of geothermal energies. It leads to the thermal pollution. Okay, students. Thermal pollution means what? Thermal pollution is one type of water pollution. So what is water pollution? Thermal pollution. So if you release, yes, I will explain. If you release hot water slowly into the surrounding water bodies, up to some extent it is beneficial. It promotes the growth of algal blooms, phytoplanktons, which further in turn results in growth of small fish, big fish. That system will goes like that. If you release hot water suddenly, sudden release of hot water from geothermal power plants into the water bodies, it results in thermal shocks, and it shows effect on aquatic ecosystem. Okay, this is one of the major problem with this geothermal energy. And one more benefit of this geothermal energy is, without fuel we are extracting steam now. If you take all the thermal power plants except geothermal energy, say for example I will list out coal, natural gas, diesel, nuclear, any thermal power plant. In all this thermal power plant, what I have listed out, everywhere we have to use the fuel. We have to convert water into steam. Steam is used for rotation of turbines. Turbines in turn results in rotation of generators, which produce electricity. But in case of geothermal energy, without any fuel, we are directly getting the steam. Are you getting my point? That is the benefit here. And that too, constant power production is possible. Throughout the year, we can produce electricity, like thermal power plants. Okay, that is the benefit regarding this. No seasonal impacts. This is the only renewable energy which has no seasonal impacts. You can take any renewable energy resources, it has a seasonal impact. Solar has a seasonal impact, wind has a seasonal impact, wave has a seasonal impact, tides has a seasonal impact. Okay, now, ocean thermal energy has a seasonal impact, but geothermal energy doesn't have seasonal impacts. Okay, now, make a note of this point. Without using the fuel, water is converted into steam. Okay, next one is, without using the fuel, water is converted into steam. Okay, next one is, it is the only renewable energy which doesn't have any seasonal impact. And constant power production is possible. Similar to like thermal power plants. Okay, students, done. So that is what geothermal energy means. Any doubt? Where? Okay. Disadvantage. So by preventing the release of hot water. They should not release hot water directly into the surrounding water bodies. They have to cool it down. After that, they have to release it. So that's such kind of preventive measures we can take. If they release it suddenly over a period of time, then it becomes a problem. Not only in geothermal, steel manufacturing industries, thermal power plants, everywhere we face this problem. Nuclear energy also. So what are the major sources of thermal pollution means? Listen carefully. Major sources of thermal pollution is one, geothermal energy, nuclear power plants, steel manufacturing industries, thermal power plants. So these are the major sources of what we call it as thermal pollution. Are you getting it? And among this, one of the sources of thermal pollution is geothermal energy. Got it, students? So this is what we're getting. Got clarity? Next one is hydrogen fuel. hydrogen fuel. So if you see this hydrogen fuel, this hydrogen fuel is known as futuristic fuel. Why it is known as futuristic fuel? On what basis we are calling it as futuristic fuel? What is the relevance of hydrogen? What is the significance of this hydrogen? For what purpose we need this hydrogen? Okay, now, what are the drawbacks of this hydrogen? What are the different types of this hydrogen? First, we need to go through the significances. On what basis India has declared hydrogen as a futuristic fuel? So first one is regarding to this characteristic features is, if you see this hydrogen, hydrogen never exists in elemental form. Okay, now hydrogen always exists in. Hydrogen doesn't exist in, means this elemental form. It always exists in the molecular form only. Single hydrogen doesn't exist. Always exists in the form of H2 molecular form. Okay, now first point you have to remember this. Next one is, hydrogen is the lightest element in the periodic table. It is the lightest element in the periodic table. Whenever any particular element is light in nature, can we reduce the weight of the engine or not? When we reduce the weight of the engine, efficiency of the fuel will be enhanced. This is one benefit. Okay, now next one is, another benefit is what means most abundant element in earth crust. Most abundant element in the, not only in earth crust, in our universe. Most abundant element in the universe. When it is mostly abundantly available, can we get it at a cheaper cost or not? 1 liter of hydrogen approximately costs around 1 rupee or 2 rupees. Hardly less than 5 rupees. Got it, students? That is what. Next one is, another one is, calorific value of hydrogen is very high. Among all the fuels, hydrogen has highest calorific value. Highest calorific value. That means energy production for each and every volume, means volume of hydrogen is very high. So when we compare with, see here also there is a difference, students. So when we compare in terms of volume, hydrogen calorific value is less. When we compare in terms of weight, calorific value of hydrogen is high. Say for example, hydrogen exists in gaseous form. When we compress it, it will be converted into liquid, and we will see the weight of the cylinder, but not the volume of the cylinder. When we compare in terms of volume, calorific value will be less. When we compare in terms of weight, calorific value is high. That means, so if you take 1 liter of petrol, 1 liter of diesel, 1 liter of kerosene oil, 1 liter of hydrogen, like that, all, when we combust this, per kg combustion, energy production will be high in case of hydrogen. That is what calorific value means. Among all the fuels which are currently existing, highest calorific value is there for hydrogen. Okay, now, always combustion of hydrogen takes place in presence of oxygen, and it results in production of water. Hence, can I say that hydrogen is the environmental friendly fuel? Yes, it is an environmental friendly fuel. So these are the benefits what we get regarding to this hydrogen. Based on these benefits, we categorize as hydrogen as a futuristic fuel. Are you getting my point, students? Okay, now done. Completed writing this, everybody. I will elaborate this. Make a note of this. It is the lightest element in the periodic table. It is the lightest element in the periodic table. Hence, when we use it as a fuel, weight of the engine will be reduced, as well as efficiency of the engine will be enhanced. Efficiency of the engine will be enhanced. Next one is, it is the most abundant element in the universe. Hence, it is cheaply available. Okay, now next one is, among all other fuels, hydrogen is the fuel having highest calorific value. Okay, now next one is, always combustion of hydrogen takes place. Combustion of hydrogen takes place in presence of oxygen. And it results in production of water. Hence, carbon footprints of India can be reduced. As well as it will be useful to achieve, sustainable developmental goals, as well as Paris Agreement. Is it right or not, students? Yes. That is what the relevance of hydrogen. And take it in, do you know? Elemental form of hydrogen doesn't exist in nature. Elemental form of hydrogen doesn't exist in nature. Okay, now it exists only in molecular form. Next one is, another point is, calorific value of hydrogen is very high. in terms of weight, but not in terms of volume. In terms of weight, but not in terms of volume. Okay, next one is another point is regarding to this is what means calorific value means the amount of energy that is produced, by combustion of 1 kg of fuel, by combustion of 1 kg of fuel with the other existing fuels, with the other existing fuels, that is what do you know means. Basic information regarding the hydrogen source. Got clarity on this? Then what are the limitations of hydrogen? Even though these many benefits are there, why India is unable to attain this hydrogen fuel economy? Why still we are focusing on what we call it as a methanol economy? I told you that yesterday methanol economy is the bridge between the fossil fuel economy to the hydrogen fuel economy. India's ultimate goal is hydrogen fuel economy, but we can't directly jump from the fossil fuel to the hydrogen fuel economy. Hence, we have chosen a middle path, that is methanol economy. Got it, students? Because methanol is the richest source of hydrogen. Once we develop the methanol technology, then we can proceed to the hydrogen fuel technologies. Okay, that means currently we are not having technology. Lack of technology is one of the major problems. Is it right or not? Make heading limitations of hydrogen. What are the limitations of hydrogen, students? Here. So first limitation is what means lack of hydrogen fuel technology. Lack of hydrogen fuel technology. That is the first limitation, students. In India, we just started developing it now. Okay, the next one is another important point is currently whatever the hydrogen that is produced, we are producing it in a very difficult manner. Okay, now production cost of hydrogen is very high, and that is followed by the transportation cost. Why? Because transportation cost. We cannot transfer hydrogen in the molecular form for a longer distance. We need to develop new technologies. Okay, development of new technologies is costly. Government of India doesn't have that much money. Okay, now that is one major problem. If we transfer the hydrogen with existing technologies, it will immediately catch the fire. Accidental rate of hydrogen is very high compared to other fuels. That is another problem. That is the reason why we are unable to transfer with existing technologies. And one more thing regarding this hydrogen is what means. So if you want to transport the hydrogen for a longer distance, first we need to convert into either methane, CH4, or ammonia, NH4. Then only we can transport in the form of these two forms. Later, after reaching the target place, again we have to separate the hydrogen from nitrogen or hydrogen from carbon, and we have to use it. That is another cost-added process or not. So like this, these are the major limitations. Hence, we are unable to use this hydrogen in a full-fledged manner. We started blending the hydrogen into the CNG. India's first hydrogen CNG plant was established in Faridabad. Okay, students. When we blend this hydrogen into CNG, what benefit we get means we can reduce the carbon monoxide emissions up to 70%. CNG is not completely 100% environmental friendly. When we add hydrogen, it further reduces carbon monoxide emissions. Okay, now availability of CNG can be enhanced. Cost of the CNG can be reduced because hydrogen is very cheap. So that because of that. So because of these many benefits, we started blending hydrogen into the CNG. That we are doing it now. Okay, now make a note like this. Second point is after this technological cost, with existing technology, it is not possible to transport it for longer distance. It is not possible to transport it for longer distance. New technological development is required. New technological development is required. New technological development is required, which requires huge investments. Okay, now that is what next one is. Another point is what means. Okay, accidental rate is very high. Accidental rate is very high. That means it immediately catches the fire. Accidental rate is very high. That means it immediately catches the fire. Done? Copy. Next one is production and transportation of hydrogen. Production and transportation of hydrogen is too costly. Production and transportation of hydrogen is too costly. So these are the hindrances regarding to this hydrogen. What are the benefits of hydrogen? What are the drawbacks of hydrogen source? If you need to transport for longer distance, in which form we have to transport it? Either in ammonia or in the form of methane, like that. And we'll go for what means types of hydrogen, not break. Types of hydrogen. They're getting types of hydrogen. I'll write it in a flowchart. Based on its source and production, it has been categorized into three types. One is green hydrogen. Next one is blue hydrogen. Next one is gray hydrogen. Okay, now this is the three types of hydrogen because gray is not available. I written like that. Okay, now. So green hydrogen means what we will do here is in green hydrogen, water through electrolysis method will be converted into hydrogen plus oxygen. and this method we call it as an electrolysis. Electrolysis, and here we use solar and wind energy. And this hydrogen we call, without any environmental pollutants, with zero emissions, we are producing hydrogen. Hence this hydrogen we call it as an green hydrogen. Next one is gray hydrogen. Means what? Here in this case of gray hydrogen, from methane, carbon dioxide plus wait, hydrogen plus carbon dioxide is produced, and it will be released into the atmosphere. Does it lead to the greenhouse effect or not? Yes. In case of blue hydrogen, what means? Methane in presence of oxygen results in production of hydrogen plus carbon dioxide. It will be trapped and stored. It will be trapped and stored. So that is what regarding the gray hydrogen, blue hydrogen. Next one is green hydrogen. In blue hydrogen, carbon dioxide will be trapped and stored. In gray hydrogen, carbon dioxide will be released into the environment once. So India is focusing currently on what? Green hydrogen. So we won't allow it to the release, we won't release the carbon dioxide into the atmosphere so that we can control global warming, climate change. We'll trap the carbon dioxide. We can do it for a longer period of time. Once we can trap with the help of plants, we can trap with the help of water. Oceans are the areas where 70% of the carbon dioxide of atmosphere will be trapped, and it is converted into calcium magnesium salts, and it will be trapped in the deeper layers of the oceans. As a part of carbon dioxide, we can trap photosynthesis. As a part of photosynthesis, carbon dioxide can be trapped like that. Okay, now all we need is we want to make the particular hydrogen production environment friendly. That is the thing. Got clarity, students? Make a note of this. Currently, government of India is focusing on. This green hydrogen production. Government of India is focusing on this green hydrogen production because it is environmentally friendly. Okay, no? To enhance the production of green hydrogen, National Hydrogen Mission was launched. National Hydrogen Mission was launched. Okay, students. That is next one is as a part of this mission. Green hydrogen is mandatory. Green hydrogen is mandatory in the following industries or areas, in the following sectors. One is oil refineries. Compulsorily they need to use green hydrogen. That is the guidelines given by the government of India. Oil refineries, one thing. Next one is fertilizer manufacturing, chemical fertilizer manufacturing. Next one is iron and steel manufacturing, bulk chemicals manufacturing, Okay, no? And this green hydrogen, completed that. And one more point you can add like this: green hydrogen is an energy carrier. In the following. The first one is blending with natural gas. First point is blending with natural gas. That means, right in the bracket, India's first hydrogen CNG plant. Was established at Faridabad. India's first hydrogen CNG plant was established at Faridabad. Okay, now it can be used as an energy storage. It can be used in energy storage. Okay, now it can be used in heavy vehicles as a part of fuel cells. Next one is it can be used in maritime and shipping. Okay, no? So what is the benefit of adding hydrogen into CNG? So reduces hydrocarbon emission up to, take do you know and make a note like this. Write like this. Benefits of hydrogen CNG. Blending. First one is, what is the first benefit? Reduces emissions up to hydrocarbon. Hydrocarbons means what? Carbon monoxide, and mostly it is carbon monoxide. Hydrocarbons means carbon monoxide emissions up to 70%. Reduces hydrocarbon emission up to 70%. Okay, now next one is, another one is, it reduces fuel consumption. reduces fuel consumption because it has high calorific value. With less fuel, we can produce more energy. Hence, the fuel consumption will be reduced. Okay. Next one is cost of the fuel can be reduced. Cost of the fuel can be reduced. Better performance of the fuel due to its high octane rating. Better performance of the fuel because of its high octane rating. That is structural carbohydrate, hydrocarbon structural rating. Okay, octane. Okay, so that is what the major benefits, and remaining things you can go through this PPT. So it is the stepping stone for hydrogen economy. India's hydrogen economy is there now. So we are going to hydrogen economy establishing. In Delhi, they are running the buses with hydrogen fuel. Every initiative will be implemented regarding the green fuels in Delhi only, because Delhi is one of the topmost polluted city in the world after Beijing. If it is before Diwali in second place, after Diwali it will be in first place. Okay, na? So that is pollution levels for the Delhi is very high. Hence we are implementing all these things here. And we'll go for the previous year questions. What are the previous year questions regarding this hydrogen? And so this first question: hydrogen fuel cells vehicle produces one of the following exhaust. What is the waste product? End product is water. Okay, na? Whatever we have studied in the notes, whatever we have listened in the class, whatever we have read in the books is always correct. Okay, na? Always UPSC questions will try to divert you. Okay, na? You should not fall on this particular trap. What you have read is correct. What you are seeing is there is illusion. Okay, na? You should bring the truth from these illusions. Okay, na? Next one is this. With reference to the green hydrogen, consider the following statement. It can be used directly as a fuel in internal combustions. Yes or no? Hydrogen CNG. Okay, next one is it can be blended with the natural gas and used as a fuel for heat or power generation. Okay, next one is it can be used in the hydrogen fuel cells to run vehicles. Yes, all these three are correct. This is this year question. Okay, now see this. Consider the following heavy industries: fertilizer plants, oil refineries, steel plants. So where this green hydrogen plays a significant role. All. Okay, na? That is. Next one is in the context of proposals to the use of hydrogen enriched CNG as a fuel for buses in public transport. Consider the following points. The main advantage of use of hydrogen CNG is to eliminate the carbon monoxide emissions. Okay, na? Hydrogen CNG as a fuel reduces carbon dioxide and hydrocarbon emissions. Okay, na? Carbon dioxide and carbon monoxide emissions. Hydrogen up to 1/5 of the volume can be blended with CNG as a fuel. Hydrogen makes the fuel expensive than CNG. Hydrogen CNG fuel makes the fuel expensive than CNG. Which one is correct? First one is correct. Remaining all are wrong. Okay, na? So these are the questions regarding this hydrogen students. Take a break. After the break, we'll go for other energy resource. Understood hydrogen? Only hydrocarbon means carbon monoxide we will take. That is the pollutant now. What is octane rating? Go for the break and come. I will give you in there. Okay. So coming to this, next one is hydropower plants. Hydropower. Is based on river systems. This is one categorization based on river systems, and next one is another categorization based on potentiality. Based on potentiality. Runoff hydropower plants. Next one is water storage hydropower plants. This is one categorization. This is age-old categorization. Based on potentiality, power plants are categorized into micro, mini, small, large hydropower plants. Micro means 0 to 100 kilowatts. 101 to 1000 kilowatts. Small means 1001 to 25,000 kilowatts. Large means above 25,000 kilowatts. This is what the categorization of hydropower plants based on potentiality. These hydropower plants, runoff hydropower plants, are mostly in perennial river areas. Perennial river system. Wherever these perennial river systems are there, runoff hydropower plants are there. In non-perennial rivers, water storage hydropower plants exist. In non-perennial rivers, water storage hydropower plants exist. You know that what is perennial and non-perennial rivers. Okay. So this is what the capacity based on potentiality hydropower plants were categorized. Small hydropower plants means it is 25 kilowatts, or we can say that 25 megawatts, 2500 kilowatts, or 25 megawatts. Okay, now any power plant which is 25 and below, we call it as small. Okay, now and 25 and above, we call it as large. Always this small hydropower plants comes under the Ministry of Ministry of New Renewable Energy. These power plants comes under the Ministry of Power. That means small hydropower plants and its below comes under the Ministry of New and Renewable Energy. Okay, now 25 megawatts below power plants comes under the Ministry of New and Renewable Energy. 25 above megawatts comes under the Ministry of Power. So hence small hydropower plants are considered as renewable sources. So in which state these hydropower plants are very high? So these hydropower plants comes under the category of what means? This small hydropower plants. It comes under the category of runoff hydropower plants generally. It comes under the category of run-off hydropower plants. Okay, now wherever perennial river systems are there this small hydropower plants intensity is very high. Means large number of hydropower plants are present. So if you see this in northern part of India, wherever these perennial rivers are there the largest number of hydropower plants exist. As well as in the southern part of India also, there exists this hydropower plants. This is from the Ministry of New and Renewable Energy website. Okay, so wherever perennial rivers are there the concentration of hydropower plants is very high. But there are benefits and limitations are there regarding this. But when we compare with these benefits and limitations, so benefits are very high. Hence, we are giving permission for small hydropower plants. We want to increase the hydropower production in India. Got clarity, friends? Okay, now next one is, if you see this, the total estimated potentiality of 21,130 megawatts from these particular sites in the country. Means small hydropower plants total capacity is this much. Okay, now write a point like this. Small hydropower plants in India. Small hydropower plants in India is mostly concentrated. In northern part of India. In northern part of India than the southern part. In the southern part. In the southern part. Okay, no? So that is what regarding this small hydropower plants. Only small hydropower plants comes under the category of Ministry of New and Renewable Energy Resource. Constant power production is possible throughout the years once with the small hydropower plants because they are established on runoff, means perennial rivers now. So constant power production is possible with this small hydropower plants. Easy to install with less cost and all. Cost becomes very less in case of this. So drawback is what means, when we establish for each and every 1 kilometer in India there is small hydropower plants. When they establish the small hydropower plants for each and every 1 kilometer, what is happening is it is showing effect on habitat of living organisms. Say for example, you know that freshwater gangetic dolphin. Have you heard about this? National aquatic animal of India we call it as. And it is popularly known as susu dolphin. It makes susu sound, which is an ultrasonic sound, which is useful for underwater communication purpose. The specialty of this dolphin is it doesn't have eyes, but it has a most powerful sonar system. Okay, now, so earlier they used to move for 50 kilometers daily in search of food, but because of construction of this small hydropower plants, they can't move. And that too, whatever the fish that is available, all fish was catched by humans. What is there left out for them? They are going for hunger deaths. When they are dying, we are not living. We are catching it and we are eating it. Okay, now these are all the threats of freshwater gangetic dolphin. Habitat has been reduced because of this. Fish availability has been reduced. You know, like this, aquatic animal life is affected because of the small hydropower plants. That is one of the major reasons for this. I'm going to make a note at this point. The major problem with the small hydropower plants is freshwater gangetic dolphins. Freshwater gangetic dolphin habitat was affected. Freshwater gangetic dolphin habitat was affected. Okay, now, green hydrogen means completely, totally green, no carbon dioxide emissions. That is what. And so many people are asking about grey hydrogen. Grey hydrogen was not given by government of India. It was given in other books. Grey hydrogen means hydrogen produced from the fossil fuels. That is coal, diesel, like that. Okay, now grey hydrogen was not given in the books. I mean, that whatever the material that was released by government of India, in that they have not covered it. Okay, now PIB material is there. Directly I will send you the material. You go through that material also. I will send you that booklet what was released by government of India. It was not covered in that. Hence I didn't mention that. Grey hydrogen means nothing but hydrogen produced from fossil fuels such as coal and diesel, like that. Okay, no, sorry, that is what we call it as brown hydrogen, not grey. Grey hydrogen means, as I told you that, methane. But brown hydrogen means, what is that means? Hydrogen produced from fossil fuels such as coal, diesel and petrol, like that. Okay, now brown hydrogen means. Remaining things I have covered it. Okay, now brown hydrogen was not mentioned in the government of India's reports. So that is what regarding, up to this we completed renewable energy resources. Check it out. All the renewable energy resources I have covered it. Okay, now next one is non-renewable energy resources, that is fossil fuels. I have covered all the renewable energy resources. Next one is fossil fuels. What are these fossil fuels means? How can we define these fossil fuels? What are the different types of fossil fuels we have? Fossil fuels are produced from where means dead remnants of living organisms. Dead remnants of living organisms. From the dead remnants of living organisms, fossil fuels are produced through a process known as fossilization. Where this fossilization takes place? This fossilization takes place in interior layers of earth crust. Interior layers of earth crust at high temperature and pressure. At high temperature and pressure. Got it? At high temperature and pressure, in the interior layers of earth crust, fossilization takes place. That we call it as fossil fuels. And these, what are these fossil fuels we have? What are the different fossil fuels we have? Coal, crude oil, natural gas. Coal, crude oil, natural gas. Got it? And next one is regarding this crude oil. What are the constituents of this crude oil we have? And what about this coal? Coal based on carbon content. Based on carbon content, it is categorized into following types. One is lignite coal, lignite, bituminous, wait, and we can write like this also, peat and anthracite. Anthracite. Anthracite has 90% of carbon content. Bituminous has 80% of carbon content. Lignite has 70% of carbon content. Peat has 50 to 60% of carbon content. This is the highest quality of coal. Highest quality coal. Next one is crude oil. Regarding to this crude oil, from crude oil we'll extract different types of products. What are the products that we extract from the crude oil is? That is diesel, petrol. Next one is kerosene oil. Next one is LPG. Next one is plastics. It will be extracted through fractional distillation mechanism. It will be extracted through fractional distillation mechanism. Next one is based on occurrence. Based on occurrence, natural gas is categorized into following types. What are the different types of natural gas that we have? One is shale gas, coal bed methane gas. Next one is gas hydrates. Okay, now like this fossil fuels has been categorized. Got clarity? Okay, now from fossil fuels what we extract. So how this formation of coal takes place, what we extract from crude oil and what we extract from natural gas, all these things. These are the things. Completed? Copied? So first, fossil fuels are the fuels which is produced in the interior layers of earth crust. Okay, now. So basically fossil fuels are categorized into how many types means? Two types. What are the two types of fossil fuels? Two types or three types? Three types. What are those three types of fossil fuels? Coal, crude oil and natural gas. So fossil fuels means the process of formation of fossil fuels is known as fossilization, which takes place in the interior layers of earth crust at high temperature and pressure zones. So coal, crude oil, natural gas. Among this, which is the most cleanest fossil fuel means? Cleanest fossil fuel is this natural gas is cleanest fossil fuel. Cleanest fossil fuel, natural gas. Most abundant is most abundant fossil fuel is coal. Got it, friends? Most abundant is coal. Cleanest is natural gas. What is that? Shale oil. Shale gas is there. Shale oil means nothing but crude oil only. See this? There is a rock called shale rock. Okay, now, shale is one type of sedimentary rock. From that shale, always shale rocks are the richest source of crude oil as well as gas. If it is a gas, we call it as an shale gas. If it is an oil, shale oil. That is nothing but crude oil. Got it, friends? That is what. Next one is, first I will start with this natural gas. What actually is natural gas? So how it differs from biogas? What is biogas? What is CNG? What is LPG? What is LNG? We need to get clarity on all these things. So natural gas first. Take it in natural gas. What are the major constituents of this natural gas? And where we are using this natural gas? Major constituent of natural gas is it consists of 95% of methane, 5% of ethane or propane. It consists of 5% of ethane or propane, and next one is 95% of methane. So where we are extracting this natural gas? Natural gas is a conventional or unconventional gas? We need to know this. Okay, now, once upon a time, this natural gas is a conventional gas, students. But now it is unconventional gas. Why it is unconventional gas? So once upon a time, why it is a conventional gas? Now why it is unconventional gas? So no doubt that it consists of methane, students. Those are the constituents of natural gas: methane, ethane, butane, propane. So 70 to 90% methane, and remaining 0 to 20% ethane, butane, and propane. That is what. Next one is where we are using this natural gas. For what purpose we are using this natural gas? So petroleum and natural gas, as I told you that it is produced from the interior layers of the earth crust. And next one is it is of unconventional and conventional. If you see NCERT books, it will be written as conventional. But when you see this, due to the advancement in technology, recently we have identified shale gas, we have identified coal bed methane gas, we have identified gas hydrates. When it comes in terms of this, it is unconventional. Because advancement in technology, we are able to identify the natural gas resources in the interior layers of earth crust, deeper layers of the earth crust. If a natural gas is available here at the top layers of earth crust, then we call it as conventional. That means you know the conventional and unconventional definition now? We can easily extract it. Okay, now unconventional means it is found in the deeper layers of the earth crust. Hence it is not easy to extract. That is what. Okay, students. Shale gas is unconventional. Coal bed methane is unconventional. Next one is other one is gas hydrates is unconventional. Okay, now, other than this, if anything is available in the top layers of the earth crust, it is conventional in nature. Okay, now no doubt that whatever that was written in the NCERT book is 100% correct. And what I am saying in the class is 200% correct. Okay, no doubt in that. If you see the Ministry of Hydrocarbons website, it was mentioned there clearly, students. Got it? Okay, next one is, after this, what is the thing regarding to the shale gas? And where we are using this natural gas, in which industries we are using this natural gas? Natural gas we are using it in the power sector, for electricity generation, fertilizer manufacturing industries, industrial purpose for furnaces, which is domestic and commercial use, automotives, and petrochemical industries. In all these areas, natural gas is used currently, students. Okay, and other than this, what are the other uses of this natural gas? As I mentioned in this thing, so how it is used in fertilizer manufacturing industries, where it is used as a hydrogen source in the fertilizer manufacturing industries. Okay, and if it is rubber industries, it is used as a carbon source. Like that, for different purposes, natural gas is used. Do you have natural gas resources? Means no doubt that India is having plenty of natural gas resources. But the problem with this natural gas is we are unable to extract due to lack of technology. We have identified wide resources. Only because of lack of technology, we are unable to extract it. Hence, there is a shortage of natural gas in India. We are importing this natural gas from other countries by constructing the pipelines. Tapi pipeline is one of the most famous pipeline regarding to this natural gas. That means we are importing the natural gas from other countries. Why we are depending upon natural gas means because it is environmentally friendly in nature, cleanest fossil fuel. Hence, we are importing the natural gas from other countries. What is this difference between natural gas and biogas? If any methane gas, when it is produced from the interior layers of earth crust from shale rocks like that, then it is known as natural gas. If the methane is produced by the degradation and decomposition of any biomass, then we call it as an biogas. Okay. When we compress both natural and biogas, we call it as an compressed natural gas. If it is biogas, we call it as an compressed biogas. And when we are transporting, after compression, this gas will be, any natural gas or biogas will be converted into liquid. And when we will transport it in the form of pipelines, then we call it as an liquefied natural gas, that is LNG. So like this, methane has different names. If methane is produced from cow dung, then we call it as a gobar gas. If methane is produced from marshy areas, then we call it as a marsh gas. If methane is produced from the interior layers of the earth crust, then we call it as a natural gas. If methane is produced due to the decomposition and degradation of any biomass, we call it as a biogas. So these are the different names of the methane. If methane is directly released into the environment, it acts like a greenhouse gas. If methane is combusted, it becomes environmental friendly. Okay, the combustion of methane gas becomes environmental friendly. If it is directly released into the environment, it acts like a greenhouse gas. And where it is used means in all these industries it is used. Are you getting it? Okay, now shall we write regarding this? Okay, next one is natural gas. Natural gas is of conventional and unconventional. Is of conventional and unconventional. Is of conventional and unconventional. Due to the advancement in technology, natural gas resources were identified. Natural gas resources were identified in the deeper layers of the earth crust. In the deeper layers of the earth crust, such as shale gas, coal bed methane, as well as gas hydrates. But due to lack of technology, these natural gases are considered as unconventional. These natural gases are considered as unconventional. And I gave you definition of conventional and unconventional. Okay. Natural gas generally exists in 4 different basic forms. Natural gas generally exists in 4 different basic forms. One is LNG. Just write the names. LNG. LNG means liquefied natural gas. Okay, now. Regasified liquefied natural gas. Regasified liquefied natural gas. Regasified liquefied natural gas. Compressed natural gas. Compressed natural gas. Next one is piped natural gas. Piped natural gas. Piped natural gas. Okay, now next one is, yes, completed writing these 4 forms. After that, you can write applications of natural gas. Applications of natural gas. It is used in electricity generation. Okay, electricity generation. It is used in electricity generation. It is used in electricity generation. Next one is, it is used in fertilizer manufacturing industries. Used in fertilizer manufacturing industries. Fertilizer manufacturing industries. Okay, now that is ammonia and urea. Next one is, it is used as a green fuel in automobile industries. It is used as a green fuel in automobile industries. Used as a green fuel in automobile industries. It can be used for domestic and commercial purpose. It can be used for domestic and commercial purpose. Domestic and commercial purpose. It is used in industries. It is used in industries. Next one is in petrochemical industries. In petrochemical industries. Petrochemical industries for production of methanol. Petrochemical industries for production of methanol. Yesterday also I gave you this in sources of methanol, natural gas. Did you remember that? Yes. In petrochemical industry for the production of methanol. Okay, no? Next one is, make a note like this. Take heading, do you know, and write like this. Take heading, do you know, and write like this. So what means? Methane. Methane, when it is released directly into the environment, when it is released directly into the environment, it acts as a greenhouse gas. It acts as a greenhouse gas. It acts as a greenhouse gas. Okay, no? When it is combusted as a fuel, when it is combusted as a fuel, when it is combusted as a fuel, it becomes environmental friendly. It becomes environmental friendly. Okay, no? Methane produced from interior layers of earth crust. Methane produced from interior layers of earth crust. Interior layers of earth crust. That is from rocks. From rocks. Then it is known as natural gas. Then it is known as natural gas. Next one is methane produced by decomposition and degradation. Methane produced by decomposition and degradation of biomass. Decomposition and degradation of biomass. Then it is known as biogas. Then it is known as biogas. Okay, no? Next one is methane produced from marshy areas. Methane produced from marshy areas is known as marsh gas. Is known as marsh gas. Methane produced from cow dung. That is gobar. Okay, no? Now it is known as gobar gas. What is gobar means? Galvanizing organic bioagro resources. Then it is known as gobar gas. Produced from cow dung. Then it is known as gobar gas. Okay, no? Next one is natural gas and biogas. Natural gas and biogas. When it is compressed, then it is known as CNG, compressed natural gas, and CBG, compressed biogas, respectively. Okay, no? So this at 162 degrees centigrade or below that, more than that, this natural gas will be converted into liquid. Then that liquid natural gas we call it as an LNG, which is used for transportation. Okay, now make a note like this. At a temperature of minus 162 degrees, it will be converted into liquid for transportation. Then it is known as liquefied natural gas. Got clarity on this technologies, all the technologies? Is it clear now? Okay, now everything will have major percentage of methane, minor quantities of propane, butane, like that. Got it, friends? Okay, that is what the natural gas constituents, where natural gas is used. And next one is what are the technologies regarding to the natural gas and all these things. So first I'll start with gas hydrates. What is gas hydrates means? From where these gas hydrates will be extracted? Have you see this? From the oceans, we will extract these gas hydrates in polar regions as well as in oceans. Where these gas hydrates are produced, how this gas hydrate is produced. Generally, it is available in deeper layers of the oceans only. So at the greater depths of the oceans, friends, if you see what happens means at the greater depths of the oceans, you know that fish will die at the any dead organic substance will reach where? In the oceans or not? Okay, now see this dead living organisms. So as the death of living organisms, what happens? It undergoes, any living organisms will undergo what? Degradation and decomposition. As it degrades and decomposes, as a part of degradation and decomposition, what will be released? Any degradation and decomposition results in release of two types of gases. One is carbon dioxide, methane. Next one is methane. Copy simultaneously. Carbon dioxide and methane will be released once. So what happens over a period of time? This methane, over a period of time, it will be trapped in the ice crystals. So I told you that methane, this methane gas, which is released as a part of this degradation and decomposition, will be trapped in the ice crystals. This is an ice crystal, and where in this ice crystals, this methane gas will be trapped. It doesn't happen in all of a sudden manner, students. It happens in a slow evolutionary process, gradual process it is. Okay, now, so methane trapped in ice crystals. Methane will be trapped in the ice crystals. This we call it as what means? This methane trap that is in ice crystals, we call it as gas hydrates. It doesn't happen in the surface of the oceans, friends. It happens at the greater depths of the oceans. So at the greater depth of the oceans, high pressure will be there. High pressure and very cold conditions will be there. That condition perfectly matches for formation of gas hydrates. So this we call it as, you can call it as gas hydrates or methane hydrates. Gas hydrates are methane hydrates. Conditions for trapping of this formation of these gas hydrates. What is the perfect condition for formation of these gas hydrates means, make a note of these ones. Condition for formation of these gas hydrates is what means? One is cold temperatures. Next one is high pressure. High pressure. High pressure. Because of cold temperatures and high pressure, methane will be trapped in the ice crystals. Methane will be trapped in the ice crystals because of this. That we call it as a gas hydrates. Next one is, these gas hydrates are available at the greater depths of the oceans. Make a note here. Gas hydrates are available at greater depths of the oceans. Available at oceans and polar regions. Oceans and polar regions. If it is ocean, it will be formed at the greater depths. Then only pressure will be maintained. As we move into the greater depths of the ocean, pressure increases. Okay, and it is available in oceans as well as polar regions. This gas hydrates is also known as flammable ice. Gas hydrates are also known as flammable ice or fire ice. It is known as flammable ice or fire ice. Flammable ice or fire ice, which is available in the greater depths of the oceans. Okay, students, completed writing this. So like that, the methane will be produced, methane will be trapped as an evolutionary process, which results in formation of gas hydrates. What is the condition for formation of gas hydrates? Means cold condition as well as high pressures. It will be formed at the greater depths of the oceans only. Okay, now, and that too, where it is available in oceans as well as polar regions. India is having longest coastline, and in Indian Ocean, surrounding the Indian Ocean, we have identified one of the world's largest gas hydrate resources, but we are unable to extract it due to lack of technology. Okay, students, hence. So repeat once again. So you better come after the class, I will repeat it for you. Okay. So, okay, no problem. I will explain for you, because these many people has to wait now. If 2-3 people are there, if I need again, I need to explain. Okay, if like that are there, I will explain. Otherwise, I will explain you individually. That's what I'm saying. If there is a dead living organism, any living organism, dead living organisms will reach the bottom of the oceans. When it is reaching the bottom of the oceans, it undergoes degradation and decomposition. Okay, now when it is going for degradation and decomposition, so as a part of this degradation and decomposition, what will be released? Methane. Generally, methane and carbon dioxide will be released. So this methane. So I told you that this mechanism happens at the greater depths of the oceans. So at the greater depths of the oceans, what is the conditions that prevails? Cold temperatures and high pressures. At this condition, whatever the methane that is released, it will be trapped into the ice crystals, which has been formed there. That happens in a slow evolutionary manner. Okay, now, these ice crystals, generally we call it as an gas hydrates or methane hydrates. We can call it as a fire ice or flammable ice. And it is available in the polar regions as well as, that gas hydrates is available only in the polar regions as well as oceans, not on the land part of the earth. Got it, students? Okay, like that. That is how the gas hydrates will be formed. And that is how the methane will be trapped into this ice crystals. Conditions necessary for the formation of ice crystals. And what is the other name of this ice crystals, friends? Understood now? Okay, now? So this is how the methane hydrates will be like. Okay, now, so completely it burns off until the methane is exhausted. So this methane hydrates, so we call it as methane clathrate, hydromethane, methane ice, fire ice, natural gas hydrates, gas hydrate. These many names are there for that. Okay, now, so how it is trapped, I told you that. I have shown you the flowchart. Next one is, so where it is available? In the deeper layers of the earth crust, especially in the oceans, it is available in these forms. Okay, now, and next one is, this methane hydrates, what is the use of this methane hydrates? As I told you that, methane hydrates, so this, here the phytoplanktons are there, and remaining all the dead living organisms will reach the bottom of the earth. These microorganisms will degrade all the dead living organisms. Degradation decomposition happens in case of what? Microorganisms. You can write here in the flowchart, microorganisms. Right here, degradation and decomposition happens in presence of microorganisms. Microorganisms will degrade and decompose this dead living organisms. Generally, what microorganisms are involved in degradation? Bacteria. Bacteria is involved in this degradation and decomposition. Microorganisms are involved in degradation and decomposition. Generally, what microorganism is involved in degradation and decomposition means bacteria. Okay, now, and any other microorganism is there other than this which is involved in degradation and decomposition means yes, fungus. Okay, now, one more microorganism is what means fungus. But underwater, at the greater depths of the oceans, we have identified so far bacteria only, students. Under the greater depths of the oceans, we have identified only bacteria. What bacteria generally means methanogenesis bacteria. That is microbial methane from the methanogenesis, methane bacteria. That we call it as a methanogenesis bacteria. Like that, methane will be released from the decomposition and degradations, and it will be trapped in the deeper layers of the oceans as well as in polar regions like that. Okay, now, so next one is, after this, what is the use of these gas hydrates? Why we are looking for these gas hydrates? See, Krishna Godavari basin is the area where largest gas hydrate resources were identified. And if we extract these gas hydrate resources, we can enhance the availability of natural gas in India. So for that we are looking for. So hence, we are trying to extract this methane hydrate resources from. Okay, now add these 2 points there. Recently, largest deposits of gas hydrate resources was identified in Krishna and Godavari basin. Followed by Andaman and Mahanadi. As well as in Mahanadi. Okay, now, next one is methane in the greater depths of the oceans. Produced due to the microbial activities. Hence, it is known as biogenic methane. Biogenic methane. Biogenic methane. So recently, this is a new students, this is in current affairs. I have added that into the PPT and you will get the PPT. So these are the bacteria what they have identified. 4 species of bacteria they have identified. Methanococcus or Methanoculus, Silicae, Barkeri, Flavescens and Megius. These are the 4 types of bacteria what was identified where the methane is produced at the greater depths of the oceans. How methane gas is formed in Krishna Godavari Basin, Andaman, and next one is Mahanadi. So these are the bacteria that is responsible for that. Okay, now, that is one thing that we call it as an biogenic methane. Okay, now, next point is these gas hydrates are available. These gas hydrates are available in polar regions as well as in oceans. In polar regions as well as in oceans. Polar regions as well as in oceans. In polar regions, atmospheric methane, in polar regions, atmospheric methane will be trapped in the ice. Will be trapped in the ice. That is known as permafrost ice. That is known as permafrost ice. Permafrost ice. Permafrost means it is the basic characteristic feature of tundra. Have you heard about these tundra ecosystems? Okay, what is the basic character of tundra ecosystem is permafrost ice. What is permafrost ice means? Ice which have been formed since million years ago. Okay, while the formation of ice, whatever the methane that is there, it will be trapped into this ice in the polar regions. Okay, like that we have identified these gas hydrates in polar regions. In oceans, it is purely to the biogenic, and in polar regions, when it comes to this, atmospheric methane will be trapped into the ice over a period of time. So, but we are trying to extract both these gas hydrate resources. Okay, now next one is for extracting of these gas hydrate resources. Government of India has established National Gas Hydrate Program. Government of India has established National Gas Hydrate Program. National Gas Hydrate Program. Okay, students. So the problem is if you are not extracting, what happens means global warming is happening. Because of this global warming, this permafrost ice will melt, and again methane gas will be released into the environment. When methane is releasing into the environment, what happens? It leads to greenhouse effect. Is it right or not? That becomes a problem or not? If you use it, it becomes green fuel. If you are not using it, because of global warming and climate change, if the ice melts, it will be released into the environment. When it is released into the environment, what happens? It acts like a greenhouse gas. Got the clarity on that point? What is the previous question regarding this gas hydrates means? This is what. So this, which of the following statements correct about these deposits of methane hydrates? Global warming might trigger the release of methane gas from these deposits. Large deposits of methane hydrates are found in Arctic tundra under the sea floors. Methane in atmosphere oxidizes to carbon dioxide after a decade or two. Methane in atmosphere. We have written this thing in our notes twice. Is it right or not? Methane. Blue hydrogen, grey hydrogen. We have written in grey hydrogen and blue hydrogen or not? Methane in presence of oxygen, it will be converted into carbon dioxide. Have you done it or not? Have you written it or not? So answer is what? 1, 2, and 3. Completed, students. Have you seen blue hydrogen? Blue hydrogen, methane in presence of oxygen results in production of carbon dioxide and hydrogen. Same in case of grey hydrogen also like that only. Got it, students? But there is carbon dioxide will be released into the environment in case of grey. In case of blue, carbon dioxide is trapped and stored. So that is what. Done, students. Understood clearly? Any doubt, students? Any doubt? Okay, now understood the gas hydrates? Okay, now. What is that? So it is a slow process. Okay, now. Okay, then. If any doubt is there, please come forward. I will explain it. Rest of the people can leave. Happy Sunday.